Hello, water managers. My name is Simon Evans, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be presenting the lecture on forecasting with ensembles in SWMS, part of the SWMS Prospect course. This is the third part of 3 videos on this topic, and in this video, we will be covering the Ensemble Forecast Processor as well as the Ensemble Viewer. The Ensemble Forecast Processor is a new plugin first available in SWMS 3.4. It's part of the program order, meaning that users can create forecasts with an Ensemble Forecast Processor alternative with any combination of other modeling applications. This allows for flexibility in how it can be used within SWMS. We will show a few potential examples later on. The Ensemble Forecast Processor is based off of work done originally in the HEC-CWMS for the FIRO Forecast Informed Reservoir Operations Forecast Processor. It allows users to specify locations within the watershed and then to calculate statistical metrics from ensemble time series. Statistical metrics such as the 90th percentile of the 5-day volume, for example. These metrics can be used as input to other applications within the SWMS forecast, and we'll look at how this works a little later on in this presentation. So there are 2 types of output from the Ensemble Forecast Processor, scalar and time series. So the scalar metrics that can be calculated are shown in the image here. The user can select metrics such as the minimum, maximum, average, standard deviation, and then also various percentiles for whatever cumulative volume is specified. These scalar metrics can be incorporated into the rules of ResSim alternative to influence the operations. So this is the approach that was done for a FIRO, a Forecast Informed Reservoir Operations case study in Southern California at Prado Dam. Time series can also be generated through the Ensemble Forecast Processor. So this allows for a reduced number of ensemble members to be used as input to other models. So for a chosen metric, let's say the 3-day 90th percentile volume, the Ensemble Forecast Processor first calculates the scalar metric and then returns the specific ensemble member that has the closest volume over the defined period. The returned ensemble member can then be used as input to the next model alternative within the SWMS forecast. So how can this be used within a SWMS forecast? One potential application of the Ensemble Forecast Processor within a SWMS forecast is what we're calling a summarized ensemble forecast. In this example, the HEFS ensemble time series are extracted into the DSS format. At locations where ensemble data is not available, gridded precip data is used as input to METView and HEC-CWMS, which generates uncontrolled flows in the watershed. Next, the ensemble DSS time series are used as inputs to the Ensemble Forecast Processor, which then computes the metric data that we just looked at. This metric data and the uncontrolled flows can then be used as input to the HEC ResSim alternative, which computes the regulated flows. Finally, these regulated flows are used as input to the HEC-RAS and HEC-FIA to calculate inundation and damages for the forecast. And then on the left, we can see what the program order would look like for a forecast run like this. Another option would be a regulated ensemble forecast. This starts the same way as the summarized ensemble forecast. First, HEFS ensemble time series are extracted into the forecast into the DSS format. Gridded precip data is used as input to METView and HMS, which generates uncontrolled flows in the watershed. The difference here, though, from the previous example, is that an Ensemble HEC-RESIM alternative is incorporated. This uses ensemble flows and uncontrolled flows as input and computes the regulated ensemble outflows. These regulated ensemble outflows are then used as input to the ensemble forecast processor, and an ensemble summary is then used as input to HEC-RAS and HEC-FIA. Visualizing ensemble time series and being able to interpret the data is a critical part of using ensemble time series. The Water Resources System Division at HEC developed the Ensemble Viewer to help fill this need, and it is now directly available from the CAVI, accessed through the CAVI toolbar and then Tools. It allows the user to view ensemble metrics, like the ones that the ensemble forecast processor calculates. This first plot shows how an ensemble time series can be viewed, and then specific metrics can be then calculated from it. The next plot here shows that the time series are cumulative, and then the various metrics can then be calculated as well. Currently, the metrics computed by the Ensemble Viewer cannot be saved. This functionality is contained within the Ensemble Forecast Processor within SWMS. This concludes the third part of the Forecasting with Ensembles in SWMS lecture. If you have questions about our software, need some help, or are looking for additional trainings, check out these links. They can also be found in the description below. Thank you for your time.